我们今天非常荣幸的邀请到来自泰国的 Dr Sanguansri 来帮我们讲解稻米的贮存对我们米谷粉成物的性质、膨润以及颗粒形态的影响。那 Dr Sanguansri 呢，他事实上他做的研究，他是目前是在曼谷这个卡塞萨 University 的十科系，应该说是10科系担任教职。他的硕士跟博士都是在美国的 UC Davis 得到的。所以他对我们食品这方面，同时他过去也做，他现在也做了很多的这个研究，相关的研究。事实上，他的一个学生目前呢，也是在我实验室在做这个访问研究的工作。那我们现在就用热烈的掌声来欢迎Dr Sanguansri。Please. The floor is yours.
Good morning. Thank you very much, Professor Ye, for a very nice introduction. I also would like to say thank you for the organizing committee for inviting me to join this symposium and share some of our work at Dr University. Before I look at the effect of rice storage on pesking property, swelling, and granular morphology of rice flour, I would like to start with to look at the finished product that use rice flour as a raw material. I guess everyone knows about this very well, which is the rice noodle. Rice stick noodle made from indica rice, and the requirement, one of the requirements is this indica rice has a high amylose content. In Thailand, most of the rice noodle manufacturers use broken rice, and a few factories use flour rice flour. And this is the rice noodle sheet that we make in our laboratory. We use the variety is Leung 11. Has about 30% amylose content. This one made from aged rice over 6 months. It has perfect shape of the cheese. And this one made from the same variety, but from the new rice, which is just harvested. With this rice noodle, it cannot be cut into the strip. In this case, the rice storage is an advantage. And some food factory, sometimes you might come across a problem of the chain of viscosity or even the texture of the food. And this another example is from our laboratory. This is a rice flour gel made from khao dok mali 105 or jasmine rice. It's an indica rice. We mix it, the rice flour with water, heat, and then cool down, and got this the rice flour gel. Look to the SEM. This one is from new rice, and the second one, this is the gel from the aged rice 12 months. And this, we took this to gel subject to freezing and thawing several cycle, and we found this. You can see that for the gel from the new rice flour, after 5 freeze thaw cycle, the texture or the microstructure still look okay. But for the gel that made from aged rice flour 12 months, you can see there is a change in the microstructure. There's some pore or some hole. Besides the microstructure, the texture of this frozen thaw gel is harder. So in this case, the aged rice flour is disadvantage. So you can see that the storage of rice affect the quality and characteristic of the rice product. I also heard that in Taiwan, with the purpose of food security, you also store some rice for 1 year. This is the step from rice to rice flour in Thailand. When the rice is ready in the field, it was harvested. And then after that is the step of stretching and winnowing. Then you get the paddy. The paddy has high moisture content, so we have to dry it. The drying can be natural as sun drying or sophisticated equipment like the dryer. After the paddy was dried, then it can be storage. And then after that, after finish the storage, it can be cleaned and milled. For milling, we got the mill rice and also broken rice. Or in Thailand, we still have quite high percent of the broken rice. So most of the rice flour, the manufacturer use the broken rice as a starting material. Sometimes we have to store the broken rice for certain time. And after that, it was ground to be the rice flour, like this. So you can see that there is two steps of the storage. This is and this storage as a paddy, and also for the broken rice storage. But if we don't have enough broken rice, then we can use the mill rice to grind as a rice flour. Before go further, I would like to talk about the use of the rice flour in the industrial level and also in the household level. This is a simple schematic. Most of the rice flour uses, they use it for, especially for food. They start with mix the rice flour with the water and then stir it. And after that, usually heat it. And most of the time, usually stir during the heating. And when we cool it down, you get the paste or the gel. To simulate this step, we usually use this machine and get the result from this machine. The machine is called Rapid Visco Analyzer or RVA. This is the main equipment. And this is my student. After she stirred the flour sample with water and then put into the machine. Put into this machine. The machine can be heated with a constant heating rate. And also the sample can cool down to with controlled constant rate. The control rate can be controlled by the computer. Also, the result also shown from this computer. What we got called pasting property. This is simplify the temperature profile that we usually program in the RVA machine. We heat the flour slurry or flour suspension with the constant heating rate to a certain temperature, mostly is 95 degrees Celsius, and then hold it for a certain time, and then cool down with the controlled cooling rate to the low temperature. And from the machine, from the computer, we will get this profile. Is pasting viscosity or RVA profile. So I would like to explain a little bit about this profile. The temperature profile is from the previous slide. Start with at the low temperature. The starch granule swell a little bit, not much when it absorb the water, but it's not increase the temperature. When we increase the temperature with the program of the machine or the equipment, the granules swell more. This one, and go to the maximum swelling. It swell the most because the volume of the granule increase to the maximum volume. It causes viscosity to get the highest. After that, we still heat it and at the holding temperature. So some of the amylose leach out and the granule, some of the granule disrupt, so the viscosity going down. At the end of the heating period. After that is the cooling period. The amylose chain align together during the cooling, and some of the granule or the fragment of the granule or some disrupted or undisrupted align together during the cooling. That's caused increase in viscosity. The whole process is took about 15 to 20 minutes, so it's quite fast. And most of the rice flour factory in Thailand have this machine to check the quality of their flour. Before go further, I would like to introduce some terminology about the RDA profile. The first one is testing temperature. It's a temperature that the viscosity starts to develop. And the maximum viscosity when the starch granules swell the most is the peak viscosity. After that, there is a drop in the viscosity, and the difference of this, the drop of the viscosity is called breakdown. And this breakdown indicates the granular stability. High breakdown means that the granule has less stability. And that is the final viscosity, is the viscosity after cooling. And the increase of the viscosity during cooling is a setback, is to indicate the extent of the retrogradation of the flour. Okay, so now come to the result of our study. For the first one is the testing property of the indica rice, which is khao dok mari 105 with 2 storage time. The first one is a new storage with new rice flour only 0.7 months. We cannot have 0. We didn't harvest it ourselves. And the second sample is a 12-month rice flour. After you can see that it's not the same pattern. Has some change in the viscosity. For the after aging, the peak viscosity reduced, the breakdown increased, and higher setback as well as higher final viscosity. Besides this indica rice, we also look at the glutinous rice flour. This is the previous result. And for the glutinous rice flour, the variety is RD6. We find the same pattern, which is with the age, right? It's about one year age. The peak viscosity reduced, increased, reduced breakdown, increased final viscosity, and the setback. The next parameter is about the swelling. For the explanation about the testing property and the mechanism, I will put it into the back of the result. As you know that rice flour, when you put in the water at cold water, is absorbed a little bit, swell a little bit, not much. So this one is before heating the rice flour and the water. But after heating at 75 degrees Celsius for 15 minutes, only 15 minutes, you can see that the rice flour swell. Now look at the effect of storage on the swelling value of the rice flour. In this table, as we can see, the first thing is when we increase the temperature. Just look at the new rice flour. We increase temperature of 65 to 75. We can see that swelling increase. This experiment with the stirring and for 30 minutes, same as the aged rice flour, the swelling increased with temperature. But if we look at the effect of the storage, we found that when you age more, the swelling is less. When we age the rice flour more, like from 0.7 months to 12 months, the swelling value decrease. But for this one, the 85, in fact, we should think that it should be higher than this value, but it's reduced. We think that because with the high temperature, 85 degrees Celsius, and stirring, and for a long time, 30 minutes, then some of the swell granules start to collapse. That's why it has a low swelling value. And if we look to the light microscope, we see that the top one is for the new rice at heat at 65 degrees Celsius, 75 and 85 degrees Celsius for 30 minutes with stirring. And this is the edge rice, the same temperature, same time. You can see that for the new rice, there is a lot of swelling compared to the edge rice. The swelling is less. We would like to propose mechanism to help explain the result of both tasting property, swelling, and those pictures from the light microscope. This is the rice flour granule. You can see the polygon of the granule inside. The granule accumulate in this particle. We use colloid view. We use colloid view for viewing it. There is some protein at the surface of the particle. And for the new rice, the protein has a sun-hydryl group, which is the SH, like this. And also besides the particle at the surface of particle, also the granule, the surface of the granule, there are some protein too. And for the new rice, it's south-hydryl, which is SH. And from the work of Punyathan and Liharatananurak, they use rice and collect it and store at different certain times. We start from 0 months to 8 months. After that, they make it as a rice flour and then extract the protein. And they use this protein and run the gel electrophoresis to see the protein pattern. And it shows that this is for the new rice, 0 month, and for the 8 month, you can see that the protein pattern has moved up to the higher molecular weight. This means that the protein of the edge rice has a longer chain. And they say it's disulfide bond formation. So there's some disulfide bond formed in the edge rice. And these protein matrix also have at the granular level too. These protein matrix restrict the swelling of the granule. Another point is we also look at the gelatinization of the rice with different storage time using differential scanning calorimeter or DSC. And this is the thermogram of the aged rice, 12 months, and the new rice. You can see that the peak, gelatinization peak, is this at a lower temperature than the aged one. And besides that, delta H, which is the enthalpy of gelatinization, is increased. So we think that the crystallinity of the aged rice is increased, and this can be the formation of hydrogen bond of the aged rice. So this is what we think happened during the testing property, during determining the testing property. For the new rice, with water, heat, and shear, get the swelling of the granule. and the granule is less rigid. But for the aged rice, with the protein and the rigid structure, the swelling is less compared to this one. And this shows in this testing property, which has the new and the aged rice. The new one with the swelling more has higher heat viscosity than the aged one. For further analysis, we have heat and shear more. The amylose come out, leach out from the granule. And for the cooling, there's some alignment of the amylose and also the disrupted the granule. But for the aged rice flour, the swelling is less. Also amylose leach out, but this rocket granule is less than the new rice flour. And the protein in the matrix for the new rice is doesn't have the disulfide bond, but for the aged rice has disulfide bond. So with this event, we can see that after cooling, the final viscosity of the aged rice flour is higher than the new rice. And this makes the doodle sheet is more perfect sheet. And as we talked before about the effect of the aged rice or storage of rice, there are advantages and disadvantages of this. I forget to tell you that the reason that we are interested in look at the frozen rice scale is because Thailand, the frozen food industry in Thailand is going up. This one is not related to the rice flour, but it's about the cooked rice. So I would like to share some results from our lab. This is the cooked rice, the same variety, which is Dr 105, new 0.7 month aging, and this one is 12 month aging. It's just cooked, and then we look at the microstructure with SEM. You can see that before freezing, the surface a little bit different, that more rough with the aged rice flour. So it's like cooked rice. And after we took this cooked rice to subject to freezing and thawing, this is the first cycle, and then the fifth cycle. In the fifth cycle, you can see that the rice with aging 12 months, it changed a lot. The surface is very rough and has some porous, while the one with the new rice, the microstructure is still okay. This result also correlate with the texture that show that the cooked rice from 12 months, 5 week thaw cycle. 5 week thaw cycle still has a harder texture and less consumer preference. So we would like to propose some example of improve the property of aged rice to be close to the new rice. To give you some idea, if you have aged rice, maybe you can try to improve its property. This is the work from Gu and co-worker in 2012. Let's see. They use Japonica rice and fresh and also aged for 4 months. This one is the FR is the fresh rice in distilled water, and they land the RVA, and they got this tasting profile. And this one is for the aged rice, 4 months. You can see the change in the tasting property similar to what, which is lower the tasting viscosity. The paste viscosity is lower, and the increase of the setback and the final viscosity. What they did is they think that this, they think it's because of the disulfide bond of the protein too. And they say that the formation of disulfide bond is an oxidation process. So they try to use the reducing agent put into the water.
Okay.
So this is what they found. They use the H, the pink, the same one, but instead of using distilled water, they use 20 millimolar, this is ascorbic acid in their symbol. You can see that the peak viscosity from this one increased to this one. So it's higher, close to the new rice. When they increase the concentration of the ascorbic acid to be 50 millimolar, the peak viscosity increased. But for the result, the final viscosity didn't move down. The next one is the work in our laboratory. Instead of using ascorbic acid, we use citric acid. The dotted line is the H, right? This is with the normal distilled water. When we run the sample with the H, right, but in the 0.1% citric acid solution, we got the red profile. You can see that the peak viscosity from this dotted line increased to the red one. And also the final viscosity reduced. And when we increase the concentration of the citric acid solution to the 0.2, we see more profound effect. We still need to figure out what is the mechanism of this, and my student is working right now. This is the simple schematic, what we think, but we didn't prove it yet. This is a starch granule, rice starch granule, and this is a protein. For the edge, right, there is a protein surround the granule, like the disulfide. So if we bring the edge right round to heat it, after heating, the granules swell but not much. That's why it has no heat viscosity. But when we add the citric acid in the solution, within that citric acid might dissolve the protein, or maybe take the protein out from the granule, or maybe disrupt the disulfide bond, we are not sure. So with the less protein chain, the swelling is increased as in here, and that's why the peak viscosity increased. Another experiment that is going on in our lab is, we think that if we don't want to use any ingredient, but we manipulate the process, is it possible to change its rice flour close to new rice flour? Maybe by a longer soaking time, or a higher speed of the stirring, or longer heating. We are not sure what is the final result. So the conclusion of this presentation is that the storage of rice reduce the granule swelling, decrease peak viscosity and breakdown, but increase granule viscosity, setback, and testing temperature. And this effect caused by protein from disulfide bond, more rigid structure of starch granule, or high crystallinity. The effect of rice storage can be advantage or disadvantage. I would like to thank the funding agency for rice research, not only the storage, but the whole rice research in my lab. The funding, we got funding from Thailand Research Fund, Kasetsat University, and at the beginning we got from National Research Council of Thailand too. I would like to thank my student, Vattini helped with the effect of storage. Kamolat helped with using the citric acid solution, and Sukanya helped with the glutinous rice. Thank you very much.
谢谢各位。